To assure the integrity of our hyper-interconnected digital systems, security is being baked into manifold layers of the Internet of Things, down to the microchips in IoT devices. I spoke to Thomas Rosteck, the head of Connected Secure Systems at Infineon Technologies, all about this.
But let me emphasize again that security is not something you can think after you have designed your product. It is like doing a cake. If you bake a cake, you have to think about the flavor of the cake at the beginning. Once you have the cake, you can't change the flavor anymore, right? And that's the same with security. You basically have to think about the security requirements and the security system of your device before you start the design. It's a huge responsibility for system architects and developers of products.
So, as systems have become more interconnected, one of the approaches is this notion of zero trust architecture. Can you connect those two dots for us? How does the embedded piece of security fit with, a key security technology approach?
What you need to do is you have to have, we always call it a security anchor, right? You have to have something in the system that you can trust. And from there, you build up your system, your trust system. And that's important because in the end, the success of IoT is also largely depending on whether people are trusting their devices. So this anchor of trust that you need and to kind of work into your system is an important piece here.
I'm curious about if you could discuss specifically things that get you excited about what Infineon is innovating that support all this, that fit right into embedding security, supporting zero trust.
Security is not just one single thing. And you have different security requirements depending on the devices. We have security that is part of our, call it standard microcontrollers, which we have upgraded with security features or even a security enclave. And if you need more than that, because your vulnerability is even higher, your potential vulnerability is higher, then you could add a dedicated security device. We have built a scheme, we call it Edge Protect, and this has like 4 levels, and it starts with basic things which are more for remote attacks. So it helps you for secure boot, it helps you for secure firmware update, things of that nature, right? And then it goes all the way to Edge Protect level 4, where we really have the physical protection means in there. So even if you try to mingle around with the chip physically, it is still protected.
Yeah. Where are these things making a difference? Where are they gaining traction in the field?
I mentioned the PCs already. This is for 20 years plus. We have it in the mobile phones, where you have your credit card credentials in the mobile phone, so they usually feature a secure element in there. Then we have it in smart home devices. So, for example, more and more robots, like your vacuum cleaner robots, have cameras with it in this whole smart home, but also in the smart building area. So actually, in the end, everything's connected, needs to be protected.
What is the role of standards in all of this? Protocols and standards, technical protocols and, compliance standards.
So its standards in principle allow for interconnectability, right, if you will. So take Matter as an example. Matter is the smart home standard where you now basically can connect the security cameras, the smart door locks, the light bulbs and so on, all to your smart home system from different vendors. So standards first provide interoperability, but they also provide a certain level of security which every device has to meet.
Yeah, that's a good example of the industry moving, as it normally always has done, to set these protocols and standards to make everything work in this acceptable, secure manner.
Right, and let me add something. 20 years ago, standards were working like, okay, I do the interoperability, and at the end, okay, sorry, I forgot security, so we add some security to it, right? Matter now is different, as an example, because as part of the Connectivity Standards Alliance, so the CSA, there is a subgroup which is product security, right? And this product security is filling into this Matter standards, right?
Yes, security is being thought of more readily as part of standards now. Let's talk about that. I mean, there's drivers there, right? There's this increasingly hostile environment, government reacting in Europe quicker, now in the U.S. for compliance, imposing security-related guidance and even regulation. How has the pressures in the threat environment and the component of government regulation come into play with respect to standards and protocols?
And what you see in the engagements with government in cybersecurity, especially for connected devices, is that they have an interest to protect, on the one hand, their citizens, but on the other hand, also their infrastructure. So last year, the US government announced the Cyber Trust Mark as a label for security of connected devices. And this Cyber Trust Mark, you will find then, once it's implemented, you will find then, for example, on the box of the TV that you are buying, or the box of the security camera that you're buying, to indicate to the consumer that there is a certain minimum level of security involved here. The EU is actually going, from my perspective, one step further. The EU has passed the so-called Cyber Resilience Act, based back in March this year. This regulation does actually also set requirements for connected devices. And how do they do this? They did not create a new label, but they use an existing label. In Europe, every electronic device that is shipped into Europe or sold in Europe has to have the CE mark, so the Consumer Electronic Mark. This Consumer Electronic Mark so far is mainly about safety, right? So CE mark says this product's not going to kill you, right? But this CE mark will now be upgraded with security. So that means, depending on the type of device that you have, there are certain security requirements. So it's powerful because it basically means that also non-European companies that want to sell in Europe need to conform to the CE mark, which they have to do today, but they now have to upgrade it with security.
So looking ahead for the next couple of years, where do you think technical innovation and standards and regulations focused on securing our interconnected systems is going to take us?
For a long time, security was not really in the mind of people, and this is changing. This is really changing. So I see a dynamic here, and now everyone has to kind of, let's say, also driven by regulations, right? Has to perform at least a certain amount of security for the products. But we also know that security is a race. So we are in it for long. So we also have to kind of improve our products all the time. So what I'm saying is security, as I mentioned, is a race. We have to continue to invest it. I'm happy that it's now going to be part of the thoughts of the system architects going forward. And with this, I'm more relieved than when we met the first time, like 3 years ago, where it was still felt more like an uphill battle. Now it's still uphill, but it's not as steep anymore, I think, right? Because there's a lot of good reasons why we should have better and more secure products.
Well, thank you very much, Thomas. I'm glad you're more encouraged now than 3 years ago, and hopefully next year even more so.
We will see. Looking forward.